comes to this, you might have to memorize this. Their domain says real except where x is equal to n pi over 2, where n is any odd integer. Okay? Tangent and secant work the same. Tangent is the best one to remember because the period of tangent is pi. It's within pi over 2 because we don't have a tangent, and negative pi over 2. Your tangent goes like this. So it kind of has its own little section. And if we're at every pi, God bless you, at pi over 2, at 3 pi over 2, at 5 pi over 2, there's our pattern. Now, cosecant and cotangent work the exact same. They say domain is all real numbers except when x is equal to n pi, and you have to make sure you qualify this, where n is any integer. You can't say any number, it has to be integer, meaning 0, 1, 2, 3. It can't be 1.2, 1.7. It's got to be any integer. They work the exact same. And if you remember by cotangent, your cotangent one has a problem at the 0 and a problem at the pi, and it goes the opposite way like this. So 0 pi, 1 pi, 2 pi, 3 pi. You'll see where the problems are. Remember, these are shifted 90 degrees off of each other, and this one's an inverse, so it's got to go the opposite way. So you are going to take this as soon as I see the word tangent, and I'm going to write my original tangent domain down. That's how I'm going to start. Now, I take my original tangent domain, and in place of this x, I put this x. So I bring that down here, and I say this is equal to n pi over 2, and I solve for x, my new x. I can get rid of my denominators, so now I've got pi x is equal to n pi. I've got to solve for x. I'm going to divide by pi. So x is equal to n, and I keep the same qualifier where n is any odd integer. So I say real except x equals n, where n is any odd integer. Now, what's your range on tangent? All real numbers, right? Tangent goes up and up and up. So does the fact that I changed this amplitude to 1/2 affect my total range? No. It affects where my points go a little bit, but my range? No. No effect on my range. So I wanted you to be able to use the fact that tangent says n pi over x is equal to n pi over 2. These are your exceptions. These are where your asymptotes go, where n is any odd integer, and set it equal to the new x. Are we okay with that? Okay. All right. The next one, use the cosecant. So we look at our cosecant, and we say cosecant uses real numbers except where x is equal to n pi, where n is any integer. So there's my starting point. I bring this out, and I start right there. I have to know that. Those are the two things I have to know, those two domain restrictions. So I take whatever this is, and I replace this x. So I brought it down here, and I said, take that x out, put an x over 2, now solve for x. So I'm x over 2 is equal to n pi instead of x is equal to n pi. I cross multiply. There's what my x is equal to, and I take the same qualifier. So my domain is real except where x is equal to 2n pi, where x is any integer. Now, when we actually graphed these out yesterday and last week a little bit, we saw those were your even numbers. So I kind of said to you, if you do it by your graph, you're going to pick 0 pi, 2 pi, 4 pi, 6 pi, where n is any even integer. We really don't have one of those qualifiers. It's either going to be an odd or any. So hence the 2n. The 2 times n makes us be even, doesn't it? If I put a 1 out there times 2, I get a 2. If I put a 3 out there times 2, I get a 6. So if you gave it to me the other way, I wouldn't mark it wrong because you used your graph, but I would like you to keep to these two things. These are the only two you have to remember. And even though we reflected this, your amplitude is still 1, so your range stayed exactly the same. We didn't change the range on this side. What does the negative do? Reflects it. So your original sine curve, instead of going up, is going to go down first. So then your cosecants go off of those little bumps. It's just going to go down first instead of up first. But the amplitude itself is still 1, even though there's a negative there. Good? Ask me questions if you don't get this. This is really, really important. So secant, I go back to my secant. Secant's like my tangent. My secant domain says all real numbers except x is equal to n pi over 2, where n is any odd integer. I take whatever this is, and I replace it in place of that x. So I bring this down, replace that x, it's still equal to n pi over 2. I have to solve for x. So how am I going to solve this for x? What should I do? I can cross multiply. Cross multiply. My x is over here. So now what do I want to do? Divide by 2 pi. I got to solve for x. It looks weird, but you just got to follow the same thing. So x is equal to, out comes my pi, and I'm left with 3 over 2n, or you could leave it 3n over 2, whatever you like to leave it as, and bring down this qualifier, where n is any odd integer. And so just like make it real, except x is equal to 3 over 2n, 3 halves n, 3n over 2 if you left it that way, where n is any odd integer. Now, I wouldn't ask you to graph this one, because what we did when we took out the pi, we're still in radians. We just made it be decimal values. So you're going to work off of, instead of angles, you're going to work off radians, and which we do, but you're going to flip them to 1, 2, 3, 4, 5. So rather than confuse things, I like to keep it where you can realize what the angles are. Because when you look at 1, 2, 3, 4, 5, even though they're angles in radian measure, you don't get the same feeling. So these we won't graph in here, but we will be able to still find its domain. And on the secant, what's going to happen too, normally my secant goes off of my cosine. So my cosine went negative 1 to 1. My secant originally went negative infinity to negative 1. And then from 1 to infinity, but I did an amplitude. What is my amplitude for this guy? 2. So I multiplied everything by 2. So negative infinity to negative 2, and from 2 to infinity. There's my new range. The negative is a reflection. That's all I want you to do last night. Just so that you get used to, like our goal the day before was to actually visualize this, see why this is happening. Then last night I just kind of wanted you not the graph, deal with the exceptions. Okay, and your last one, I'm working off of a cosecant, which works like my cotangent. So I start with my original graph, and I say, okay, just take this guy and replace it with this x. So I say 2 pi x is equal to n pi. I have to solve for x. So what do I have to divide by? 2 pi. Out comes the pi. So x is equal to n over 2, where n is any integer. There's my domain. Real except x equals n over 2, where n is any integer. Now the 1/2 changed my range. It shrunk it down a little bit. So instead of going from negative infinity to negative 1 and 1 to infinity, I just multiply this by 1/2. So my new range goes here. The negative 1/2, and it starts at the 1/2. Does this make any sense? Does this make a little bit more sense? For those of you that weren't here yesterday,